Hey everybody, welcome to SES Engineers' mini webinar series focused on carbon sequestration and deep well injection. Today, Mr. Spencer LaBelle will discuss how capturing and sequestering carbon dioxide protects our delicate ecosystems. Spencer serves as a senior project engineer and has 8 years of experience in civil and environmental consulting for stormwater and erosion control management systems, site development, regulatory compliance, and planning. He has a degree in environmental and ecological engineering from Purdue University with a minor in natural resource and environmental sustainability. Spencer, turn it over to you.
Thank you, Stephanie. So we're going to be talking today about how protecting ecosystems is achieved with carbon sequestration and carbon capture. So I first want to start by discussing where carbon dioxide comes from. Carbon dioxide is a naturally occurring gas, which is important to recognize. It's necessary for photosynthesis, if we remember that from our elementary school science days. It's also generated through volcanic eruptions and other natural combustion events, like a lightning strike in a forest. And it also makes up 0.03% of the atmosphere. While it is a naturally occurring gas, it is also generated from human activities, which include burning fossil fuels like coal, oil, and natural gas. Deforestation, which is cutting and burning of trees, which are designed to capture and hold carbon dioxide. It's also generated through different industrial processes. It's generated from transportation, as a lot of us know. And it's also even generated when we send a text message. We hear the term commonly used, your carbon footprint, or what is the carbon footprint of my calculator or my phone? When we speak about that, we're talking about carbon dioxide being emitted into the atmosphere. I also show this graphic from the US EPA, which shows a distribution of human-generated carbon dioxide and the different percentages from transportation, the electricity industry, other industries, residential and commercial, and other non-fossil fuel combustion and that breakdown. It's important to understand that carbon dioxide in the atmosphere has a balance. And that balance is generally between the levels of 280 and 300 parts per million. That level is generally established for the time and the measurement of carbon dioxide in the atmosphere before humans initiated burning fossil fuels, as you can see on the graphic. To the left, the measurement of carbon dioxide in the atmosphere never really exceeded 300 parts per million until we reach about 1911 or 1920s in the Industrial Revolution. As you can see in the other graphic to the right, the measurements currently have exceeded 300 parts per million and steadily have increased throughout our current day, where we're approximately at 420 parts per million. So as you can see, these human-generated activities are starting to get the concentration of carbon dioxide in the atmosphere out of balance. The measurement of carbon dioxide in the atmosphere is important because there is a balance, as we've discussed, and carbon dioxide in the atmosphere is necessary. Carbon dioxide allows some solar radiation to stay in the Earth's atmosphere while letting the rest of the solar radiation emit into space. That solar radiation is important because it generates heat for our planet, and heat is responsible for the movement of air in the atmosphere. That movement of air generates weather, which creates growing seasons and allows plants and animals to change based on the heat in the atmosphere. When we have an abundance of carbon dioxide in the atmosphere, what it does is it increases the heat trapped within the atmosphere, as you can see in the graphic. That excess heat and temperature change affects weather patterns, and we get heat waves, droughts, more frequent wildfires via lightning strikes, more frequent hurricanes, and more frequent extreme weather. In addition, that heat warming the world's water, it reduces the sea ice acreage, which increases the absorbed solar radiation and also affects the change in weather. Increased temperatures and changes in weather patterns impact both wildlife and ecosystems. It increases habitat loss. It modifies migration capabilities. It modifies growing seasons and geographical ranges of different plant species, which then affect the geographical ranges of different animal species. It also modifies seasonal breeding patterns. As we know, animals are accustomed to and adjust based on the seasons. That being out of whack based on the heat and the temperature adjusts those breeding patterns. In addition, all of this kind of congregates in altering competitive relationships between both plants and animals. The importance of capturing and storing carbon dioxide is critical to achieve balance for the carbon dioxide concentration in the atmosphere. Carbon capture and sequestration is the process of storing that carbon dioxide so that it doesn't emit into the atmosphere. And this process is commonly referred to as creating carbon sinks. There are two different types of carbon sinks that are used today. The first is geologic, which we'll get into. The second is biologic, which is creating more plants and trees and space for those plants and trees to collect carbon dioxide and store it. So not cutting them down or not burning those trees. The geologic process is storing carbon in saline aquifers or other geologic units. And this process requires a very rigorous permitting, investigation, and evaluation process before anything begins. It requires an in-depth geologic investigation and characterization. It requires geophysical modeling, which uses physics, chemistry, and a variety of geologic principles to evaluate the feasibility of storing the carbon dioxide. It also requires a monitoring and assessment plan before anything is injected. And this process is very stringent in order to evaluate the efficacy of the cap rock and storing the carbon dioxide. This process is, as I mentioned, very stringent. The permitting process usually takes between 18 months and 2 years before any injection begins. But this is a valuable method to create more carbon sinks. So how does carbon sequestration help protect ecosystems? Storing carbon dioxide is critical for stabilizing the atmosphere and getting us back into balance. That will then allow wildlife and ecosystems to adapt and restore back to that original balance. Geologic sequestration is a very important process that can be used to increase the carbon sinks. It's designed to have a small footprint, which is very valuable for maintaining land space for wildlife and preserves. It also provides a very safe vertical separation between the supercritical carbon and the ecosystem that resides above. It also has an established monitoring program to safely store that carbon dioxide. And it is a permanent storage option. In order to protect ecosystems and restore the balance, we need to use a combination of sequestration methods, which includes geologic and biologic, and expand those carbon sinks in order to get our concentration of carbon dioxide back into balance. Thank you, Stephanie, for letting me present and discuss how carbon sequestration can protect ecosystems.
Absolutely. Thank you, Spencer. We appreciate that helpful overview. That was a good plain language explanation of carbon dioxide and the benefits of sequestration to our ecosystem. Spencer is joined by several of his colleagues on the SES team who have presented numerous topics in this mini webinar series. Please check all these pre-recorded webinars out and stay tuned for more upcoming topics that we've got in development right now. In the meantime, feel free to reach out to Spencer or for me for more information. or scan the QR code on this slide to learn more about how we can help you. On behalf of the entire SES carbon sequestration and deep well injection team, thank you for tuning in today.